I want to give you a few hints on number 34 and 37 from our assignment. So if I take a look at number 34, they're giving me this information. If b equals 14 and a equals 30 degrees, determine the possible values of a for each situation. So essentially what we're doing is for these three choices, A, B, and C, we are trying to figure out what the value of A would be. So the first thing I want to do is convert this into the language that we've been using off of our notes. In our language, D, angle D, capital D, would be 30 degrees. A is the thing we're trying to find. That's the thing opposite A, angle A, so that would be our letter D. That's the question mark. And B would be our M. Okay, and then what we want to do is we want to use our notes here to decide, and I'll start with letter A here. How are we going to end up with no solution? So I've got no solution in this line right here, and I have no solution right here. It's got to be one of those. Since case 3 is about angles that are bigger than 90, I have to shoot for case 1A. So I know D is less than 90, right? And I need D to be less than M, so D is going to be less than 14. And then we need to have D also be less than M times sine D. So I also need D to be less than 14 times sine of 30. So I'm going to multiply 14 times sine of 30, and I'll figure out what the values of D need to be. When I multiply 14 sine 30, I get 7. So in this case, D needs to be less than 7, and that checks out here as it's less than 14. So for letter A on our assignment here, for letter A, as long as D is less than 7, then I will have no solutions. Let's see if we can figure out letter B. We know D is less than 90, and we know that D has to be less than M, so less than 14. How are we going to get one solution? Well, I'm going to check out one solution right here, and that means that D has to equal M times 7. M times sine of D, which is 7. So for letter B, D has to equal 7 so that we get case 1B. For letter C here, two solutions. I'm going to leave that for you to figure out the rest, but I hope that it's pretty clear where we're headed with this. When D is less than 7, there will be no solution. When D is equal 7, there will be one solution, and then I'm going to leave you to figure out what happens or how we end up with two solutions. But it all has to do with taking a look at the value of D and then, of course, looking at the relationship between lowercase d and lowercase m. And that leads us to case 1. Okay, let's take a look at 37. We'll give you some hints on that too. A satellite is orbiting Earth every 2 hours. The satellite is directly over a tracking station, which has its antenna aimed 45 degrees above the horizon. The satellite is orbiting 1,240 miles above Earth, and the radius of the Earth is 3,960 miles. How long did it take the satellite to pass through the beam of the antenna? So before we get started, let's talk about this question, how long? We're really trying to figure out how much time it took to go from here to here. And we know that the satellite goes around the Earth every 2 hours. So it takes 2 hours to go 360 degrees. And then what we need to do is write a proportion to solve for the amount of time that it takes. So we'll finish that off in a second. To get to that, let's draw a little bit bigger version of this picture so we can see what's going on. That beam I'll put in red like it is in that picture. But a lot of the information in the story we can use to fill in the rest of this triangle. Remember, this is in a law of sines section, so you figure we're probably going to have to use a law of sines. So first of all, we know that this distance from the center of the Earth to the surface is 3,960. And we know that the satellite was 1,240 miles above the Earth. So if you add those two together, you get 5,200 miles. And then the other piece of information that we know is, here's the horizon, and this is 45 degrees, and the horizon hits the distance, the radius of the Earth at 90 degrees. So this whole angle is 135 degrees, this whole thing here. And with that, we can figure out this angle. Now remember, they want us to calculate theta, but we don't have any information about the red side. The best we can do is get this angle over here. And let me just call that angle A. I'm gonna figure out what angle A is so that I can get theta. And I'll do that by just running through the law of sines. So what I'm saying is the sine of A over the opposite side, which is 3960, is going to equal the sine of 135 over its opposite side, which is 5,200. And so to solve for A, I'll do the inverse sine on that calculation. And the calculation is going to be the sine of 135 divided by 5,200 times 3960. And we'll do that calculation and we'll figure out how big angle A is, and then I can use that to solve for theta. And that works out to be about 32.6 degrees. So if that is 32.6 degrees, then this angle down here, angle theta, is going to be 180 minus 135 minus 32.6. And that equals about 12.4 degrees. Okay, so here's how you're going to finish this problem off. We know that angle theta is 12.4 degrees. What we need to find out is how much time passes when you rotate 12.4 degrees. So your job will be to solve this proportion. It'll be a decimal number, which will be measured in hours. And if you want to figure out how many minutes that is, multiply it by 60. So solve for x. Solve this proportion for x. And then do x times 60 to get the minutes. Because x is a decimal in terms of hours. Okay, so that's my hint on number 37. Good luck on these problems. Let me know if you have any other questions.